Hello students, welcome in our class. So today I come again with the same topic which is magic square matrix you see. I come again with another new question and we are going to solve again with some another method. And before I starting this session, I request you to please check the previous video. We have already covered one lecture on magic square matrix, which is a research question from our team. We have researched a very interesting question, and in the last lecture, we have not discovered the observations also. So, the purpose of this lecture is to observe the observations here. Okay, okay, now let us start our session. So, okay, fine. So the question is already written as you see. It is written the find the inverse of a magic square matrix and check whether it is also magic square matrix or not. So before that you see here I have already mentioned here that which standard students will study this lecture. It is for class 11th, 12th and engineering students. So if class 10 students are watching this, it is on their own interest. We are not here to criticize them. Okay, so now uh, those who have already covered our previous lecture, they know that I have already explained them what is a magic square matrix. So if you want to understand this magic square matrix, again I am requesting to you, please check out that video. Now this time I have taken another matrix. You see, it is a matrix A. So, as I already mentioned, how to uh, identify that this matrix is a magic square matrix or not. So, first of thing is that it should be a square matrix, and you see it is a square matrix of order 3 by 3, right? It has a 3 columns and 3 rows, so it is a 3 by 3 matrix. It is a square matrix. Now is this how this square matrix will become a magic square matrix? So we have to check the condition of the magic square. So if you add, what we have to do, we have to check that here the first condition is that every number should be different. You see, every number in this, or you say every element in this matrix is a different number. It no number is repeated here. Okay, so this is the first point. You maybe know already about the rules of the magic square, but I am again specifying with you so we can discuss the topic after that. Now if you add these three elements this row side, you will add, you will get 45. Again if you will add from the second row, you will get 45. From third row also you will get 45. From corner you will add, you will get 45. And from column wise also you add, you will get 45, 45, 45. And this corner also you get 45. Okay, it is your task. You can add very well, and you will find that every element, if you add it, you will get 45. So you also uh, convey me if I am doing any mistake in the comment section. Okay, so like the last lecture, we have did one mistake, but actually that determinant has to come minus 360. Okay, so it may be a spoiler for this lecture, but if you see the previous lecture, this will not be a spoiler. Okay, now you add all these things, you will get 45. Okay, now let us look over the contents again. Every lecture we will start with the contents, because the discussion is always taking based on the consideration of the contents. So here we have some different method. In the previous lecture, we have used the method of uh, eigenvalues, eigenvector, characteristic equation, all these things we have used. But in this case, I am using the old method which has already studied by class 11, 12th, and also engineering students already studied that method we will use. So as the first case, we have to find the determinant of a matrix. Okay, we have to find the determinant of a matrix. After that, we have to find adjoint of a matrix. So if you know how to find a adjoint, we need minors and what we say, minors and cofactors. We required minors and cofactors, but that is a very lengthy process. So I'm here going to tell you one shortcut formula, and for class 11 and 12 students, those who are preparing for JEE mains or JEE advanced, for them also it is very helpful. When they have to find the inverse of the matrix, they need to find the adjoint of a matrix. So I am going to share with you the shortcut formula of this adjoint matrix. Okay, so it will be very helpful for you. And then at last we have to find the inverse of a matrix, and we will see some observations, and we will put some conclusion of this after the two questions, the previous lecture question and this question. We will take into consideration, and we will discuss the conclusion. We will put a conclusion for that. Okay, after that, for you only, we are also covering some special topics out from this session. We are showing you a making of a 3 by 3 magic square, and also we will discuss a 4 by 4 magic square also using your date of birth. So any number you can, any 4 by 4 matrix can be a magic square matrix if it is satisfying the necessary conditions of the magic square. But the special magic square we can make in a 4 by 4 manner is using the date of birth. Suppose whatever may be your date of birth, you use it and you can make a magic square. And in the last part, I will share with you about the magic square matrix of a 4 by 4 matrix. So without wasting any more time, so let's deep into it. So the first case is written to find the determinant of the given matrix, and it is also written the matrix here. So we have enough space to find the matrix, so we can observe this matrix A, and I am just writing directly the determinant. Okay, in the last lecture we have to write the matrix, and then we have to find the determinant. I have not that much space, so here I have written here, our team has written here, so that it is very good for us to observe the matrix also here and find the determinant. So do you know already how that why we need to find the determinant before finding the inverse? So because we know the formula that to find the inverse we use this formula, 1 upon that A times adjoint of A, right? We use this formula. So if this is what determinant that A, If it is equal to 0, then it is not exist, you know already. If not equal to 0, then there is a inverse exist. This is a shortcut for class 11 and 12 students, and also you know how to calculate, right? You know A into A inverse is equal to I. You know this. So there is also a method. You have to make this in terms of I, and this will become A inverse, then ultimately it becomes a inverse. Means this is like a transformation. I'm not discussing here. Okay, so let us go into the solution. Now we have to find the determinant of the given matrix A. So I am requesting to you that you also calculate the determinant, because there may be a chance of getting mistakes here, so we have to clarify also. Okay, so determinant of A can be calculated as 14 times 15 into 16 minus 11 into 17, and minus times 19, it will be 13 into 16 minus minus 18 into 17 plus 12 times of 13 into 11 plus 18 into 8. To 15. Please check is everything alright. Okay, so let me check. 14 times 15 into 16 minus 11 into 17 minus this is 19. This 9 is looking like a 4. Then I will by mistake consider it as a 14. Then I will get a wrong answer, right? See, uh, okay, all right, everything is right. So 14 times, okay, so let us just a minute, students, let us go one more step. Instead of writing the answer directly, the first you simplify the bracket one. First you simplify the bracket one, and then we will simplify the whole simplification expression. Okay, so if you multiply the first bracket associated with 14, you will get as 53, and minus 19 times of, if you see the second bracket associated with 13, you will get minus times 98. It is 98, okay, plus 12 times of, so the third bracket associated with 12, okay, will give you minus 127, and the final answer is coming out to be just a minute, students, I'm finding the answer. Yeah, it should come 1080. Okay, it should come 1080. So this is the determinant. Okay, next. Now we have to find the adjoint of the given matrix A using the trick as shown. So take a deep patience, then take a deep patience, then keep pay your all the focus on the lecture now, because we are going to find the adjoint of the matrix and we are going to use the trick. So what is the trick is that, first of all, you pick up the central element 15 and write it down in the right hand direction. After ending of 17, come back from the previous one and complete up to 15. Means you have to do like this: 15, 17, 13 and 15. Like this you have to come up. Now again pick up the center one, 15. Now you have to go in the same manner in the downward direction, and after the ending of this lowest element 11, you have to come to the upper element and again go downward, and you have to write this 15 from the starting 15 also only. From the starting 15 only you have to write. So let's see how it is coming: 11, 19 and 15. Like this you have to come up. Now we are going to check the second element from the column. It is 11. Let me once again clear this for you. Now from taking second lowest element, that is A32 element 11, and we are going this way. So how it will come from 11, after that it is 16, it will come 16, then it will come 18, then it will come again 11. After starting, you have to end with the same number. If you starting from 11, you have to end it with 11. Like that, in the case of 15, you have started from 15 and you have also ended the 15 in both the direction. Okay, in vertical also and in horizontal also. Now let us go to the third element of the column, which is this one, 19. So take the 19th element and go straight forward like this. Up to that I think you understand what we are going to do now. So 9 after 19 it is 12, then it is 14, then it is 12. Okay, it is 14. Yeah. Now again the last 15. After 15, 17, 13 and again 15. So look once again here. I have started with this 15 and I am going in the row direction. I am finishing also with 15, and same phenomena happened in every row. See, the second row is started with 11, also end with 11. The third row started with 19, it should be end with 19, not 12. Okay, we have to check continuously. Okay, it is started with 15 and ending with 15. It is happened in the row and also same way it is happened in the column. See, see the column. Now we are looking from column. From column it is started with 15, ending with 15. Second column you see it is started with 17 and ending with 17. Third column started with 13, ended also with 13, and fourth column is the same way, started with 15, ending with 15. Okay, this is the first step you have to do. Up to now you feeling very lengthy, I understand, but this will be very much helpful for you. Now, uh, what we have to do now, from starting with 15 only, we are going to find the minor of this value. Like, you find the minor same way, and you have to make a 3 by 3 matrix like this. You have to make a 3 by 3 matrix. Suppose you have solved 15 times 16 and subtract with 11 times 17, and you will get one answer. It will be 53. So I will write this 53 here, and then now I have to go successively. I have to go. So 17 times 18 and 16 times 13. I have to go like this in this direction. So if you find 17 times 18 minus 16 times 13, okay, you will get minus 172. I guess minus 172. No, it is coming 98. Okay, it is coming 98. But you remembered, right? The adjoint, when we find the adjoint, we transpose the matrix. So according to you, you are going this direction, and you have to write the element in this um, this way. But you don't write this way. You have to write here. Otherwise, if you first find out, if you find all the elements like that, then you have to transpose. But as the space is very less, I'm doing directly. Okay, so likewise, if you go to the third, one, like this you have to go. Sorry, students. Now 13 times 11 minus 18 times 15, on solving you will get minus 127, and you have to write here. This is the first method. No, I mean the first step. Now coming to the second step, now you have to go like this: 11 times 12, then 19 times 16. Now you have to go 11 times 12 minus 19 times 16. Upon solving, you will get one answer, which is minus time 172, and you have to write here now. As because we have transposed the matrix, according to you, this minus 172 should be written in place of 98, but it is transposed. That's why we are writing here. Okay, so this way you have to go. Okay, now, so you see, already I have arranged this one for you. Now this is, now again I am explaining 15 times 16 minus 11 times 17. Now I will make a matrix. Then again you have to go this way: 17 times 18 minus 16 times 13. Then you have to go 13 times 11 minus time 18 into 15. Like this you will go, and upon solving you will find the final matrix as 53, 98. Oh, sorry. minus 172, and then sorry 127 minus 172, this is 7. Okay, let me write clearly. Then 8, then 188, this is 8. Okay, and 143, then minus 82, and then minus 37. Okay, so this is the matrix. My handwriting is not good, please try to write it. You solve by yourself and write down the answer. So maybe you did not believe first time it is you are watching, but if you go in your generalized method also, you will get this is matrix, and this matrix is the adjoint of A. This is adjoint of A. Okay, now we have find the adjoint of A, and we know the determinant, and that determinant is not equal to 0. That means that is why we are finding the adjoint. We know that if it is not equal to 0, inverse exists. So we know now the inverse, and now you have to use this formula. A inverse is equal to 1 upon that A times adjoint of A. So now we have found this value. This is the adjoint A. This is our determinant, right? Okay. Now we know all the values. We can put the values here. Now we got A inverse is equal to 1 upon 1080 times, it will be coming T3 minus 172, 143, and 98. This is 8. Okay, let me erase it. I have to write it clear, right? 98, 8 minus 82 minus 127, 188. Oh yeah, and minus 37. This 82 is not looking good. So again I am writing. So finally this is our A inverse, and this is a special inverse because it is the inverse of a magic square matrix. Okay, it is a inverse of a magic square matrix. Now what is the question is there? It is asked to find that whether it is a magic square or not. So what we have to do, let us add all the elements. If you add this direction, the first row, you will get your answer as 24. You can do it yourself and you will find the answer as 24. If you do the second one also, it is 98. Okay, it is 98. uh, it is also coming 24, and 120 minus 127 plus 188 minus 37 also coming 24. And if you watch through diagonal also, is 24. Likewise, if you add all the elements, you will get your answer as 24. So up to this step you understand that it is a magic square matrix, but this is not the actual observation we are going to find the we are going to know the observation, because it is this is yeah, this is a inverse matrix, but it is a partial. The totally, if it has to be inverse, then this determinant has to divide inside the element, right? So actually we are not dividing this element, because if you see what will happen actually, if you multiply this determinant, then you see this 1080 is in the denominator, and in every element 1080 will be in the denominator. We are not converting into decimal for now. And if you add all the numbers, you will see that 1080 becomes the LCM, the denominator becomes the LCM, and these three numbers will be added up. So that is ultimately I am doing directly. So if you see, if you multiply 1080 in 1 by 1080 in the matrix, so you will actually get the answer as 24 by 1080. 1080. Okay, wait, again I'm writing. It is 24 by 1080, and if you simplify it, you will get one interesting result. It will come as 1 upon 45. Okay, little bit typing problem, that is not big issue. 1 upon 45 you will get. So did you find any observation? See, we know the matrix A, which is a magic square matrix, and the sum of all the elements came as 45, if you remember now up to now. But if you see the inverse, we have find the inverse. So if I have inverse it, also the sum also gets inversed. The sum also gets inversed, right? It is also gets inversed. So like you can, if you want to understand in algebraically, you can see algebraically. If I will say, then see, algebraically if you see that a becomes a gives 45. Now if I will do this way, 1 by a is equal to 1 by 45. It is like transformation. I am just transforming it, and for now I am assuming that 1 by a is a inverse. It is in algebraically we are considering, then it will be 1 by 45. Okay, now now let us take a fresh page to understand you. So this is your a inverse. Now we are putting some following observations. If you know that the first lecture I have given you the inverse matrix. Let me write down here that matrix. I have given you 276, 951 and 438. Okay, and we find out that every sum coming as a 15. Every sum came as 15. Okay, you understand. But if I, when I find out A inverse, the sum came as 1 upon 15, means it is also gets reciprocated. So this is the first observation. I am putting the observations from the first lecture only. And if you have found out the A square, it has a behavior like DT matrix. It has a behavior like identity matrix. Please check out once again the first lecture. There only I have explained to you that how it behaves like a identity matrix. So, and there we have found that here like this, here it is 91, 91, 91, 67, 67, 67, 67, 67, 67. This type of behavior came. So yes, if you multiplying 2 times matrix A, which is a magic square matrix, it will behave like a identity matrix. This is another observation. Okay, you can also con consider as a conclusions also. We have no have we don't have a slide of conclusions, so this is the conclusions. Okay, you can write down the conclusions I'm dictating here. So the first conclusion is the sum of the elements in a row or a column or a diagonal of a magic square matrix is becomes reciprocated when we have calculated the inverse of that magic square matrix. Once again I am repeating, the sum of the elements of a magic square matrix along a row or a column or a diagonal is becomes reciprocated when we calculated the inverse of that magic square matrix. And second conclusion is that when we uh, multiplying the magic square matrix A two times, that is A square, it will gives a behavior like identity matrix. Okay, once again I'm repeating, if a magic square matrix A is multiplied twice, that is A square, it will gives a matrix which somehow behaves like an identity matrix. Okay, so all the observations I put here, and also this question also same way, you have finded the matrix sum as 45 and you have find the matrix as 45 and its inverse we did, you found it the sum as 1 upon 45. Okay, so these are the observations we are putting. So up to now you may have, I think you cleared now how to calculate the magic square matrix. It is you can say that it is also, the magic square matrix is also magic like a magic square. You can see this magic also happened. Now, okay, so now we are coming to the special topic we have arranged for you here. Okay, maybe other videos you can find out, but also I am sharing with you. So what is the conditions for a a square to be a magic square, the conditions are that every number should be different and the sum from each of the row or column or diagonal should be equal, right? So how to make that one? So let's see. You have to take in mind which numbers I should take which would be different first. I have to take or I have to pick up the number which should be different. So let us take 1 to 9, it is different. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the 9 numbers which we have arranged here. So now what we have to do, make a diagonal like this and same in different other direction. Okay, yeah, one more line. So now you can see, let me mark here this. I'm marking the empty spaces. You can see the blue dots which are the empty spaces. Okay, these are the empty spaces. Now I'm erasing it. Now you see, okay, I'm taking different color for an understanding. So what I will do, I will put this 7 between 5 and 3, 2 and 6 in this direction I am watching. And similarly this 3 I will put like 7 I put here. I have put the 7 here. Same way I will put the 3 here. So it will come here. Okay. Sorry. Redrawing it. Okay. And similarly this 9 I can put this 9 along this direction. This is in this direction. I will put here, and this one I will put here. Okay, now we have to just look this one. This one we have to look now. So if you arrange it in a standard way, you can see it is like you can observe this way also, or you can observe this way also. I'm double lining it. Any way you can observe. Now I'm observing this way. You will see it will coming 492 and 357 and 816. So this is a magic square. If you add it, you will find it is 15. Here also 15. Everywhere, even in diagonal also coming 15. So this is the uh, given question. Okay, I have just that matrix is transposed here. If you transpose it, uh, if you transpose it 4 times, you will get the the given question in the previous lecture. Okay, so once again I am going to explaining this one to you. Now we will take another one. Now let us take this second question, and this is the question 11, 12, 13, 14, 15, 16, 17, 18 and 19. Same way we have to take it. put this 17 here. Okay, I'm just taking different color. Put this 17 here, put this 13 here, put this 11 here, and put this 19 here. Now you have to observe this one. So 14, 19, 12, 13, 15, 17 and 18, 11, 16. See, it is the given question, right? The given question I have explained to you are okay. For 4 by 4 matrix, we don't have the trick like this trick to make the 4 by 4 matrix, but we have a special condition to make a 4 by 4 matrix. You can use the birthday also. So I'm going to use the 4 by 4 matrix here. Okay. So in the last lecture I have given one homework on APJ Abdul Kalam's birth date, which is 15 September 1931. So this 1931 I am splitting in two part. Now consider 15 as A, 19 as B, and 9 as B, 19 as C, and 31 as D. Okay, and now you see. Okay, first of all, let me tell you one thing, that all credit goes to our beloved mathematician S. Ramanujan. Okay, because our mathematician S. Ramanujan has given one matrix like this 4 by 4 matrix. He also used his date of birth and make a matrix. So any date of birth of yours you can use and make a 4 by 4 square matrix. So actually this is the formula. So now see, I have considered A as a 15, B as a 9, C as a 19, and D as a 31. So let me make, yeah, it is a magic square, but I'm going to put it in a matrix also. So look here, you have to put these values A, B, C, D. Now next row you check D plus 1, which is D31. Okay, okay, D plus 1 means 31 times plus 1. It will come as a 2. C minus 1, C is 19, minus 1, it will come as 18. And B minus 3, it is coming 6. And A plus 3 coming 18. You can do yourself also. And B minus 2 coming 7. And A plus 2 is coming 17. And D plus 2 is coming 30, what, 33. And C minus 2 is coming 17. And C plus 1 is coming 20. And D minus 1 is coming 30. A plus 1 is coming 16. And B minus 1 is 8. See? Okay. Now how will you say that it is a 4 by 4 magic square matrix? Okay, one more observation you can see here. So suppose consider this column. Forget about the constants present here. Just you see the column, the variable A, B, C, D. In every column, if you observe carefully, you will see that every column every column the variables are not repeated. In each of the column, variables are not repeated repeated corresponding to rows or corresponding to column. You see, in both cases you can see it like there A, D, B, C. So once this D gets this second position in this column, it will not get again that second position in other column. After that, you see the third column, it is D not in the second column, it is in the fourth column. This third column, it is in the third position. Yeah, it is position. Okay, this is a position, and in the fourth column, it is in the top. Okay, so likewise, same case in the uh, row also. I think you are understand up to now. Now we are going to check. Now we are going to check that how it is a magic square matrix already given in the question. If you add it, what will you get? It's coming 74. Check the second row also. In the 3 by 3 matrix, there is a condition that all the numbers not to be repeated. But for 4 by 4 matrix, this rule is not agreed, not fulfilling. It is not following this rule. The numbers can be repeated in this magic square matrix. You can see this 18 is repeated, this 17 is repeated. Okay, so repetition is allowed here. This is what 33. Please write it clearly. It is 33. Okay, 74. Everyone will come 74. This is our observation. Okay, so as I told you that I will explain one point in regarding this 4 by 4 matrix. The point which I want to share with you is that when we try to find the inverse of a 4 by 4 matrix, first of all, it is a 4 by 4 matrix. It is very difficult to find out. You can use your scientific calculator also. There are some of the scientific calculators are present in which you can do the operations of matrices. From there you can find the 4 by 4 matrix inverse also. But what will be the conclusion? You will find that only diagonals are the exception in that case where the sum is not going to be equal. If you find the inverse of this matrix using the scientific calculator, you will find one matrix, inverse matrix, definitely. But that is not, that will not give you all answer as 1 by 74. As I have given the observation conclusion that if it is 74, then its inverse sum of the row or column will come as a 1 upon 74. But that is an exception in case of the diagonals. In both the diagonal, don't consider only the diagonal of the matrix. Both the diagonal is not satisfying that condition. And the reason of that happening is that it is not followed one magic square rule, that is unrepetition of number. That repetition of the number is not allowed in the magic square actually, but when we are considered about the 4 by 4 square matrix, we have to go with the repetitions also. So due to the uh, allowance of the repetition, that inverse is not satisfied all the conclusion, all the conditions. Okay, So I have explained the points, I have shared the points with you, and you can also use your talent and find the inverse of this matrix, and see whatever points I have said is true or not. If it's not true, then you can consult me in the comment section. Till then, thank you. So I hope you are also solving this question I have given in the last lecture. Please go through it. And also, once again, I am suggesting you to please check out my previous lecture before this lecture, so that you will understand the things which I have explained it to you. Till then, thank you and bye bye.